So we've looked at A and B. Now we're going to look at C and D. Okay. We called these, when we did them with other functions, we called them left, right, horizontal translations or vertical translations. In Trig, they call them phase shifts because you're changing how the graph looks over an infinite amount. Basically, you're just shifting it left or right, and the phase looks a little different. But if you say horizontal translation, I'm fine. Okay. I'm going to write left, right, up, down. That's what I'm going to write here. So sine of x minus 30 degrees. What does that 30 degrees do to the graph? Moves it to the right by 30 degrees, right? Moves the whole thing right 30. What about 2? Sine of x plus 2. Moves it up 2 units. How do you know that that is a d value and not a c value? It's not moving it left and right. Yes, if it was in brackets like that, it would be a c value. Okay? Since it's not, you're going up. Okay, sine of x plus 60 minus 1/2. What have we done? There we go, left 60, down 1. And that graph, just so you can see that we actually start changing graphs here. There, that was not it. There we go. That is the graph. So we moved it 60 degrees to the left, so you can see that peak has been moved. And we moved it all down 1. So our max is now 0 and our min is -2. But has it changed the amplitude? Because you would go 0 minus -2, which is 2, divided by 2, which is still 1. The only thing that changes the amplitude is your A value when you multiply it, and the only thing that changes the period is the B value when you change it like this, when you multiply by a constant, okay? These just move the graph up, down, left, right. All right. There we go. Left 60, down 1. What about this one? Last one here. What's wrong with the way it's written? Move the 45 over, plus 45. And then what have we done? Right, 45 degrees and up 45 units. So the graph is way up there. Okay. So horizontal phase shift would be your C value. Vertical translation is called a vertical displacement when you're talking about trig functions. I'm not too worried about that terminology. Okay. All right, we're not going to do that table because that's just kind of a same thing. This table here is just a summary of everything. But we've already looked at the amplitude, which is max minus min over 2 from a graph, or the A value. Period is 360 over B, or 2 pi over B for sine and cosine. Horizontal phase shift, you go right if it's positive, left if it's negative. Vertical displacement, you go up if it's positive, down if it's negative. This formula is only if you're trying to get it from a graph, okay? So if you're trying to pull the D value from a graph, you would use that formula. And I'll do one example of that in a sec, okay? And then the tangent, same thing as before. You can't do the D value from a graph because you don't know the max and the min, okay, for a tan graph. All right. Next page. Let's do all right, so here's our general equation. I'll write it right here. A sine b x minus c plus d. We are doing a horizontal phase shift at 3 pi over 5 radians left, and we go 4 units up. So what is my equation? I'm not worrying about A and B because I haven't said anything about those, so we just assume they're 1. So we're just talking about C and D. What is the equation for this graph? Sine of what if we've gone left? There you go, x plus 3 pi over 5. And we've gone 4 units up, so we tack on a plus 4. That's it. Okay. Let's do B, and we'll do B in both these. Okay. We have to figure out amplitude, period, horizontal phase shift, vertical displacement of all these. So, and then tell me what we've done. So, A, B, C, and D. Okay. What's my A value? Just the A value. Negative 2/3. What does that mean? It means two things. What have we done? What does the negative do? Flip over x. What does the 2/3 do? Vertical stretch by 2/3. What is my amplitude? So the amplitude of the graph is 2/3. Remember, it's the absolute value of that A value. Okay, B value is what? What's the B value? 1/4. What's the period? How do you find period? Two pi over B. So if I put my B value in there, what do I get? Eight pi. You flip the fraction and multiply. So 8 pi. All right. C and D. What's C? We're almost done here. I know this is a long class. 5 over 12, which means we went which way? Right. 5 over 12 units. D value is 3, so we went up. Okay. Second to last question here. We're almost done. Okay. A value. -1, which is a flip. What's my amplitude for this graph? Yes. Hasn't changed. Okay. What's wrong with the way it's written inside the brackets? Yes. That's like multiple people said that. So you have to factor out a 2. So you pull a 2 out, and I get x minus what? Pi over 4. plus pi. Okay, what is, so b is 2. What's my period? Which is pi, yes. So the period is pi. What's my c value? Which means we went, and d is pi. So we go up. Exactly the same stuff we did in transformations, except it's just with trig functions, okay? The only trick is amplitude is always the absolute value of your a value, and the period, you have to take your b value and use the formula 2 pi over b, okay? And make sure you factor out, but it's the same thing. I have one more question and then we're done. I know this is like long, but we're gonna skip all this graphing stuff. Normally we would do that. I'm gonna go right to the end. Okay. So we have our 4 values, A, B, C, and D for sine and cosine graphs. Which ones affect the domain of the graph? I.e., they would introduce asymptotes or, asymptotes or undefined points. Do any of A, B, C, and D do that? No, they're just constants, right? So none of them will affect the domain. Which ones will affect the range? How high and how low you go? No, which A, B, C, or D would affect? A and D, right? Because A will multiply it and D will shift it up or down. So A and D. Which ones will affect the amplitude? Just A, right? Because your A value is your amplitude, the absolute value of that. Which one is the only one that affects the period? Which one affects the zeros? Remember, zeros are x-intercepts. So boom. Which one will change those values? C is 1, because it'll move it left, right. What else? B will, because if you expand or contract it, you're multiplying by a constant. And there's one more? Not A, because A just moves like this, right? It's the D value. If you move it up, it'll change them all as well. So it's B, C, and D. Sorry, Alex. Okay. I'm just going to give you this formula. Look at the range. The only 2 variables that affect the range are the A and the D value. The max, well, the range will be A plus D, right? Whatever the amplitude is, plus whatever you shift up or down. But also because your graphs look like this, and you've got a negative A, you have to take that into account. So it's negative A plus D. Those 2 things will give you the range of your function. So for example, if I have this graph or this function here, and I say, what is the range of this function? The only 2 things that affect it are our A value and our D value. So to get the range, I just go 3 plus negative 4, gives me negative 1. And the negative of 3 plus negative 4, which gives me negative 7. So the range is between negative 1, that should be it, negative 7 and negative 1. All right, the graph would look like this. That'd be negative 1, and this would be negative 7. Okay. I'm done. Oh, you want questions, don't you? You were all on the edge of your seat for questions. I could tell. 1, 2, 7, 9, and 11, COVID version. There you go.